Alright, in this video we're going to talk about constructing and graphing exponential functions. Alright, so we're going to first start with a table of values. So they gave us x and f of x. We're going to use 2 points to write an equation for each function shown. So the parent function, the general form of an exponential equation is f of x equals a times b to the x. So now I have to figure out what is a and what is b. Well, to get b is going to be my common ratio. That's what I'm finding. So to get b, I'm going to take the second term and divide it by the first term. So 18 divided by 6 gives me 3. Okay, so that's going to be b. And then if I use the first ordered pair, which is 0, 6, f of x is 6. So I'm plugging f of x, I'm plugging 6 in for f of x. A, I don't know what that is, so I'm just going to leave it a. Well, now I know that b is 3, so 3. And I know that x, the x value that goes with f of x of 6 is 0. So x is 0. Now anything to the 0 power becomes 1. So this becomes 6 equals a, because 3 to the 0 power is 1. 1 times a is just a. So a is 6. So now I know a and b, so I can write it as an exponential function. So it's f of x equals 6, which is a, times 3, which is b, raised to the x power. Alright, so this one, same thing. Use the 2 points to write an equation. So it's exponential. It's not changing by the same, like increasing by the same amount, adding. It's increasing by exponentially, so by multiplying or by dividing. So f of x equals a bx. B is 21 divided by 84, the second term divided by the first term, which gives us 0.25. Or 1/4 if you want to write it in fractional form. So I'm going to plug in all the pieces I know. So 84 is f of x. A, I don't know what it is. B is 0.25, and it's raised to the 0 power. Anything raised to the 0 power becomes 1. 1 times a is a, so a equals 84. So then f of x equals 84 times 0.25 raised to the x power. Complete the table using the domains -2, -1, 0, 1, and 2 for each function shown. Then graph. So they gave us a function rule, f of x equals 3 times 2 to the x power. They gave us the domains, the x values to use. So I'm going to plug each one of those in and figure out the f of x value, and then I can graph it. Okay, so if I plug in -2 for x, it'd be 3 times 2 raised to the -2. Now remember, when I have negative exponents, I'm going to make it a fraction. So it's going to be 3 times 1 over 2 squared. 2 squared is 4. So it's going to become 3 times 1/4. Multiplying fractions, no big problem. Top times top over bottom times bottom. So you can make that 3 a fraction by putting a 1 under it. And that would give us 3/4, or 0.75. So my first answer is 3/4. The next one, it's going to be 3 times 2 raised to the -1 power. So I have a negative exponent, so I'm going to make it a fraction. So it's going to be 1 over 2 to the first. 2 to the first is 2, so it's 3 times 1/2. When I multiply, it's 3 over 2. Alright, the next one, I'm going to plug in 0. Anything to the 0 power is 1, so this becomes 3 times 1, which is 3. The next one, I'm going to plug in 1 for x. So it's going to be 3 times 2 to the first power. 2 to the first power is 2. So it's 3 times 2, which is 6. And then the last one, it's going to be 3 to the second power to the second, or 3 times 2 to the second power. 2 to the second power becomes 4, so it's 3 times 4, which gives me 12. So now I have ordered pairs -2, 3/4, -1, 3/2, 0, 3, 1, 6, and 2, 12. I'm going to change 3/4 and 3/2 to decimals, so 0.75 and 1.5. So -2, I'm going just up to 0.75, so not even up to 1, and this graph is counting by 2's on the y-axis, so it'd be real close to 0. For -1, I'm going to be in between 1 and 2, so at 1.5. At 0, I'm going to be at 3. At 1, I'm going to be at 6, and at 2, I'm going to be at 12. So you can see it's starting to curve. Your exponential functions are always going to have a bit of a curve to it. So there it is. it's going to be growing exponentially, so it's going to shoot up real fast. Okay, so once it starts going, it's going to just keep going up, 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 up. Alright, complete the table using the domains -2, -1, 0, 1, and 2. Okay, so f of x equals 4 times 1/2, 0.5, raised to the x. So I'm going to plug in -2 for x. I have 4 times 0.5 to the -2. So that'd be 4 times 1 over 0.5 squared. 0.5 squared gives me 0.25. So I have 4 over 0.25. 4 divided by 0.25, which makes 16. So my first answer is 16. The next one, I'm going to raise it to the -1 power. So it's going to become a fraction, 1 over 0.5 to the first. 0.5 to the first is 0.5, so it's 4 over 0.5. 4 divided by 0.5 is 8. The next one, I'm going to plug in 0 for x. Anything to the 0 power is 1, so this becomes 4 times 1, which gives me 4. The next, I'm going to plug in 1 for x. 0.5 to the first power is 0.5, so this is just 4 times 0.5, which gives me 2. The next one is I'm plugging in 2 for x, so 0.5 squared would give me 0.25, so it's 4 times 0.25, which gives me 1. So all my ordered pairs are there. Now I'm going to graph them. -2, 16, -1, 8, 0, 4, 1, 2, and 2, 1. And you can see it's starting to curve, and there it is. Alright, this one, graph each function. They didn't give us a table of values, so we're going to come up with them on our own. We want to have some negatives, some zeros, some positives, most likely. So we'll do -2, 0, and 2. Okay, and on your test, if you're asked to do these without a table, I will give you the x values to use. But on your EOC, if it's not given, make sure you pick a negative, a positive, and a 0. Alright, so I'm going to use the rule -2 times 3 to the exponent of whatever my x is. So the first one is going to be -2 times 3 to the -2. That negative exponent is going to come down into a fraction, so it's going to be 1 over 3 squared. So it's going to be -2 over 3 squared. 3 squared is 9. So it's going to be -2 over 9, which gives me 0.2 repeating. So my first answer is -0.2 repeating. The next one, I'm going to plug in 0 for x. 3 to the 0 power is 1. So this becomes -2 times 1, which is -2. The next one, I'm going to plug in 2. 3 squared is 9, so this is -2 times 9, which gives me -18. So I plotted my ordered pairs, -2, -0.2, so really close to 0, 0, -2, and 2, -18. And that's enough to kind of have my curve there. Alright, this one, y times 1/2 to the x. I'm going to use -1, 0, 1, and 2 in my table. So when I plug in -1, 1/2 to the -1, okay, so I'm going to make it a fraction, 1 over 0.5, 1 divided by 0.5 is 2. Okay, so whenever it's a fraction to a negative power, you kind of flip it and you square the bottom piece, or then the top piece. Okay, so it's 3 times 2, which gives you 6. Or change it to a decimal and make it a fraction. 1 over 0.5, 1 divided by 0.5 would give you 2. The next one, I'm going to plug in 0. 1/2 to the 0 power is 1, so this is 3 times 1, which is 3. I'll plug in 1. 1/2 times 1 would be 3 times 1/2. 3 times 0.5, if you're using a calculator, would give you 3/2 or 1.5. And the next one, I'm plugging in 2. 1/2 squared is 1/4, which is 0.25. So 3 times 0.25 gives me 0.75. So now I'm going to plot these points. I have -1, 6, 0, 3, 1, 1.5, 2, 0.75. So you can start to see that curve, and it's going to get closer and closer to 0.